don't work. I've already removed them from your homework, number 4 and 7. So they've already been withdrawn from your homework. So if you haven't started that section yet, you should see them, so you should be okay. All right, so go ahead and let's try this one. Okay, and then be sure, draw your 3 lines. Okay. Let's just make sure we're all on the same page. Okay. Let's just remember that and means both, and or means at least one. Okay. Now, when we're doing this, we're just looking at 3 separate intervals. This interval, and that interval. So we're asking, are both of these shaded in? And the answer is no. Are both of these shaded in? And the answer is no. And then are both of these shaded in? And this time the answer is yes. So over here, so then our answer is 7 comma infinity. Now do the same thing over here, but when you do each interval, ask yourself is if at least one shaded in. Okay, so let's look at this first interval. Is at least one of these top two shaded in? And the answer is no. Is at least one of these shaded in? And the answer is yes. So we'll keep that endpoint. Okay. And now is at least one of these shaded in? And the answer is yes, they're both shaded in. So then our answer is 2, 7. I'm sorry, 2 infinity. Okay. Now, yesterday when we talked about this, we said there's sort of three ways to attack this to ask this problem. I can ask it where both of these lines are going in the same direction. And then I can ask you that as an and or question. Or they're going opposite directions, but there's some overlap. And then the last way is if they're going opposite directions and no overlap. And then I did all of these for the and. I did both of these for the or. So the only one that we're missing is this one over here where they're going different directions, but there's no overlap. So let's try doing that one.
But all three can apply for and or.
Yes, yes, yes. Essentially, if we were to sort of make a little crib sheet, if I have something that looks like, let's say, this, and we're to think about these in terms of intervals. If I were to say and, that's what this would be. If I were to say or, that's what it would be. So the and requires two of these to overlap. The or requires only one thing. Okay. If we were to look at it, this one here, where I have one going this direction and one going that direction, if you ask me where their overlap is, that would be and then or would be all the way across. Right? Or is at least one. At least one of these is shaded in, at least one of these is shaded in, at least one of these is shaded in. Over here, they're both shaded in only right here. And then for the last one, so the and is equal to does not exist because there's no overlap. And then the or will be the exact same thing.
But the or you would answer using the U, right?
Yes, yes. And then that's the part we haven't explained yet, so I'll explain it in a second. I'm going to give everyone a chance to copy that. I'm going to put up the next problem just for you to have time to think about it. So go ahead, copy that, and then let's do the next problem. So you're going to have 1, 2, 3 again. Okay. So go ahead and do the at least one. So when we do this, is at least one of these shaded in? The answer is yes. Is at least one of them shaded in the middle? The answer is no. And yet, is at least one of these shaded in? The answer is yes. Okay. So then what this turns out to be is, so if we think of this as negative infinity to infinity, is that we have two disconnected intervals. There's a little gap in between them. And then the way we bridge that gap is we use this, which is called union. Okay. Now, usually what I do on your upcoming quiz is I give you one and question, one or question. One question is usually fairly straightforward like this, and the other one I make you work for it a little bit. So let's start with this problem. go 9. And let's go, yeah, that problem looks good. Okay. So the first thing you have to do is you have to simplify this side and simplify that side so it looks like this. Okay, so go ahead and do that. Okay, so isolate that x. And then divide both sides by 2. Okay. Now, go ahead and do the same thing with the other side. Okay, and then we're going to add 1, add 1. And then when we don't divide both sides by -5, x is less than -2. So when we go ahead and let's and then let me emphasize the trick here. Remember that when we divide by a negative number, we have to flip it, right? So because this is negative, you have to flip this. When we're dividing by a positive, we just keep it the same. Okay. So go ahead and now do the and part.
The symbol that we flip, it's called a compound inequality.
Oh, okay. So good question. The compound part means and and or. The inequality is basically less than, equal, greater than equal. Okay. So when we say compound inequalities, we mean ands and ors for the compound, and the inequalities are the less thans and the greater thans. Okay, so go ahead and do this. Go ahead and do that. So what we're looking for is both. Are both of these shaded in? No. Are both of these shaded in? No. Are both of these shaded in? No. So this is empty, so we say do not exist.
Professor?
Yep, go ahead.
When I checked Canvas today, the course for Math125 wasn't there.
That's weird. Okay. I'll take a look at it. That's generated by the school, not me. So I'll just make a note to see if it's there or not. And if it's not there, I'll email the admissions officer who's supposed to add it.
Okay, thank you.
So let me
Yeah, I didn't see it either, and I thought I got dropped from the class, but it says I'm still enrolled under managed classes, so I kind of.
Yeah, those are two different systems. As long as it's under PeopleSoft, as long as you are under the enrollment system, you're good. The Canvas system is not connected at all to it. In fact, none of our systems talk to each other, which is why stuff like this happens. Okay, let me check and see what's going on with it, why we're not connected. Okay, and I'll come back to you guys tomorrow on that. Okay. Let's finish over here. Let's do one more. Let's try this one. Okay, let's try doing that one. Oh, actually, you know what? Let me make this a -9, not a positive 9. That's better. Okay. Let me actually check for Canvas right now. Okay, it should be there now. That one was my fault. I guess you're supposed to publish it. So you should see an empty thing, and then you should be able to get to the tutoring from there. Okay, so I think I fixed it. If you don't see it again, let me know and I'll relook at it again. So let's play with this one a little bit. I could bring the x over here by subtracting x on both sides. You could also just add 4 to both sides. And then remember that when we switch sides, we have to flip the inequality. Okay, so now this one is minus 6 minus 6. Now, since we're dividing by a positive, we don't flip that. So go ahead and do that problem.
Professor,
Mhm.
so for 3x is greater or equal to negative 15, the sign will only switch if the 3x is a negative?
Yeah.
Okay.
If that coefficient right here is negative, that's the only thing that makes it flip.
Okay, thank you.
Mhm. Yeah. Remember, the smaller number comes first. So make sure you have the negative 5 over here and the 9 over there. So over here we have this. And over here we have this. So make sure we're doing an OR. You're doing it at least one. So we can ask ourselves, is at least one of those shaded in? And the answer is yes. Is at least one of these two shaded in? The answer is yes. And is at least one of these two shaded in? The answer is yes. So your answer is negative infinity to infinity.
Professor, does it matter if it's brackets or parentheses?
Yeah, whenever you're doing anything that has infinity, it always has to be a parentheses next to the infinity.
Oh, okay.
Okay. Okay, so go ahead and finish copying that. I'm just going to erase the left side, and then we're going to start section 2.10. We'll probably be here in 2.10 for probably about an hour and a half. In most sections, this is considered, this is broken up into two sections. In XYZ, it's considered one section, so it'll be a little bit longer than what we usually do, which is fine. Okay, so if you feel like, oh, this section feels very long, yeah, it's usually considered two sections, not one. Okay, so go ahead and copy that, and then just put the title up. Okay, so what we're going to talk about now is absolute values. Now, the absolute value of 5 is equal to 5, and the absolute value of negative 5 is equal to 5. That's the way we're used to thinking about it. I give you this left side, and you give me this right side. Now, the first question is, well, why is that true? So first of all, these two bars mean absolute value. Okay. What absolute value means is the distance from the center. Now, the key word here is distance. If I was to ask anyone in this class and go, hey, how far do you live from school? Some of you would say 4 blocks. Some of you would say about 2 miles. None of you would say negative 4 blocks, and none of you would say negative 2 miles. If I asked you how tall you were, you'd give me a positive number. I'm 5'8". You wouldn't say I'm negative 5'8". If I asked you how much you weigh, you'd probably slap me in the face if you're a girl. But if you're a guy and you were proud about your physique, you would give me a positive number. Whenever we give someone a unit of measure, meaning that how tall are you? How far do you live from here? How tall is that building? We always give a positive number. So when we talk about absolute value, the center of our world on a number line is 0. And whether I'm on this side of the number line or this side of the number line, if I asked you, how far is this from here? And we just took a ruler, right? We just took a ruler and we measured it and we go, oh, that's about 5 inches. Same thing here. If I go, well, how from this point over here, how far am I? And I took out a ruler and I just measured it. Oh, we'd say, oh, about 5 inches. There never would be a time where we go -5 because we're not weird. So the reason why absolute values are always positive